Next question is, find the overall gain of the system shown in the given figure. So, very important question which is generally asked in the examinations. So, here this is the question given, and from this diagram, first of all we have to find out the number of paths which are existing in the given figure. So, here this is the path number 1. So, I can write P1 directly here, like the gain in the P1 is G2, G4 and G6 and the second path, this is the second path, I am writing P2 which is equal to G3, G5 and G7. Similarly, third path, this is the third path, I can write here P3 is equal to G2, G1 and G7. So, fourth path is this one. So, P4 can be written as G3, G8 and G6. So, there are two remaining paths are available. So, I can write like this. This is the path. So, P5 can be written as G2, G1 minus H2, G8, G6. This is path number 5. Similarly, path number 6 is, so here this is G3, G8 minus H1, G1, G7 like this. So, path number 6 is G3, G8 minus H1, then after G1, G7. So, there are 6 number of paths. So, I can write k is equal to 6. So, there are 6 paths available, and individual loops are there, 3 individual loops are there. This is the first loop, this is the first loop and this is the second loop, and the third loop is like 8. So, there are 3 individual loops are there and 2 non-touching loops are there. So, these 2 loops are non-touching with each other, loop number 1 and loop number 2. So, that is all related to this problem. So, here I have written already the path gains, forward path gains P1, P2, P3, P4, P5, P6, and I am writing loop gains, individual loop gains here from the diagram. So, I can write P11 is nothing but between node 3 and node 4, this is G4 and this is minus H1. So, P11 can be written as minus G4 into H1. Similarly, P21 is between node number 7 and node number 8. So, this is G5 and here it is H2 minus H2. So, this P21 can be written as minus G5 H2 and P31 is between the nodes 3 and 4, similarly 7 and 8. So, it is like this. This is minus H1, this is minus H2. So, this is G8 and this is G1. So, P31 can be written as minus into minus will become plus here. So, it will be G1, G8, H1 and H2. So, two non-touching loop gains are there. So these two loops are non-touching with each other, P11 and P21. So non-touching loop gains are written as gain product of two non-touching loops. P12 can be written as P11 as well as P21. So which is nothing but minus G4H1 into minus G5H2. So resultant is G4 G5 H1 H2. Now we can expand the transfer function is as shown 1 by delta summation k pk delta k. So here k is equal to 6. So therefore we can expand this formula like P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 plus P5 delta 5 plus P6 delta 6 divided by delta. So first of all we will calculate delta, then after that delta 1, delta 2, delta 3, delta 4, delta 5 and delta 6. So delta is nothing but 1 minus summation of individual loop gains plus gain product of all possible 2 non-touching loops minus gain products of all possible 3 non-touching loops, like that. So it can be written as 1 minus of individual loop gains, here P11 plus P21 plus P31 and plus all the combinations of first 2 non-touching loops, only P12. So that can be written as 1 minus G4H1 minus G5H2 plus G1 G8 H1 H2, and P12 is here G4 G5 H1 H2. So this is nothing but here 1 plus G4 H1 plus G5 H2 plus minus G1 G8 H1 H2 plus G4 G5 H1 H2. So here calculation of delta 1, delta 2, delta 3, delta 4, delta 5, delta 6. If we calculate this, then the problem will be completed. So here delta 1 is nothing but the part of the graph which is non-touching with the first forward path. For that we need to calculate the delta. So this is the delta 1. So for this part, this is the delta 1. So this is the first forward path, and for this first forward path, this part is non-touching with first forward path. So for this part we have to calculate the delta. So delta is nothing but 1 minus of summation of individual loop gains. So here it is a loop gain G5 and H2 minus G5 and H2. So what will be the value of delta 1 here? 1 minus of minus G5 H2 is nothing but 1 plus G5 H2. Similarly for delta 2, this is the second forward path. So for this part is non-touching with second forward path. So therefore for this value delta 2 can be written as 1 minus of minus G4 H1. Delta 3, so this is a third forward path which is touching all the parts of the graph. So there is no non-touching part of this diagram in this third forward path. Similarly fourth forward path, it is also touching all the parts. So there is no non-touching part. So delta 5 is also touching all the parts, delta 6 is also touching all the parts. So only we are having delta 1 and delta 2, and the remaining delta 3, delta 4, delta 5 values are equal to 1. So if you substitute there, I am writing here delta 1 is equal to 1 minus of part of the graph which is non-touching with this is G5H2 individual loop gain. So I can write here 1 plus G5H2. So similarly delta 2, 1 minus of minus G4H1. So it can be written as 1 plus G4H1, and delta 3, delta 4, delta 5 and delta 6 are equal to 1 minus of something 0 is nothing but 1. So substitute all the values here, then this will be our transfer function. T is equal to P11, P1 delta 1. So it will be G2, G4, G6, delta 1 is 1 plus G5H2 plus P2, G3, G5, G7 into delta 2 1 plus G4H1 plus delta 3 G1, G2, G7 into delta 3 is equal to 1. So delta 4 G3, G6, G7, so G8 into 1, delta 5 sorry P5 is minus G1, G3, G7, G8, H1 and P6 minus H2, G1, G2, G6, G8 divided by the delta value 1 plus G4H1 plus G5H2 minus G1, G8, H1, H2 plus G4, G5, H1, H2. So this is the transfer function of the given diagram. So next problem is find the overall gain C of s by R of s for the signal flow graph shown in the figure. So this is the signal flow graph which is given, and for this we have to calculate the overall gain, that means C of s by R of s, transfer function for this signal flow graph. So if you clearly observe this diagram, first of all we need to calculate the forward paths, number of forward paths from input source to output source. So here it is, this is the first forward path. So I can write P1 is equal to G1, G2, G3, G4, and the next forward path is like this, coming here. So P2 can be written as G1, G2 and G6. So there are two forward paths are there in the given signal flow graph. And next step is to calculate individual loop gains. Individual loop gains we have to calculate. So first of all check whether how many individual loops are there. So this is the first loop. I can write P11 which is equal to minus G2 into H2, and second loop is there here, G5, P21 is equal to G5, and there is another loop here, P31 is equal to G2, G3 into H1. So there is a negative sign, and fourth is there here, this one, P41 is equal to minus G2, G3, G4 into H3, and if you clearly observe another loop is also there. This is another loop. So this is another loop, P51 which is equal to G2, G6, H3 minus. So there are 5 individual loops are there. There are 5 individual loops. First one is this one, second one is this one, third one is this one, fourth one is this one, and fifth one is this one. 5 individual loops are there. And we have to calculate how many individual loops are non-touching with each other. So if I calculate this first loop, P11 is non-touching with this one, that's it. So it is touching with all the loops, and if I take this one, sorry, if I take the second loop, it is touching all the non-touching loops. This is also touching all the non-touching loops, and if I take this one, it is non-touching with this second loop. So there are two non-touching loops available in this diagram. First one is this loop and this loop. Second one is this loop and this loop. So there are two non-touching loops are available in the given diagram. So I can write here the gain products of first two non-touching loops like this. Gain products of two non-touching loops are P12 is nothing but here this P11 along with P21. So I can write here minus G2 H2 into G5 or minus G2 G5 into H2. And the second non-touching loop is this loop with respect to this second loop. So this one is G2 G5 into H3, G2 G6 into H3. So this is the P51 into P21. Second non-touching loop is P51 into P21. So I am writing here minus G2 G5 G6 into H3. So there are two non-touching loops are available. So by that we can calculate the delta here. So delta is equal to 1 minus of individual loop gains P11 plus P21 plus P31 plus P41 plus P51 plus gain products of two non-touching loops P12 plus P22. So I can write here 1 minus G2 G3 into H1 minus G2 into H2 minus G2 G3 G4 H3 plus G5 minus G2 G6 H3 plus two non-touching loops are there here minus G2 H2 G5 minus G2 G5 G6 H3. Okay. Now we have to calculate delta 1 and delta 2. As there are two non-touching there are two forward paths, we have to calculate delta 1 and delta 2. So delta 1 is nothing but the part of the graph which is non-touching with the first forward path. So if I take delta 1, so this entire this first forward path is touching all the parts of the graph. So there is no remaining part which is non-touching with the delta 1. And if I take this forward path, this part of the graph is non-touching with the forward path. So for this value I have to calculate the delta 2. So delta 2 is equal to 1 minus of individual loop gain is G5. So it is 1 minus of G5. So delta 1 is touching with all the parts of the graph, hence it will be 1 minus of individual loop gains plus 2 non-touching loops minus 3 non-touching loops, resultant is 1. Delta 2 is 1 minus of individual loop gain is G5 plus there is no 2 non-touching loops, there is no 3 non-touching loops, hence it will be 1 minus G5. So by that you can directly write the transfer function. Transfer function is equal to delta P1 delta 1 plus P2 delta 2 divided by delta. So P1 delta 1 is G1 G2 G3 G4 into 1 plus P2 is G1 G2 G6 1 minus G5 is the delta 2 divided by the value of delta 1 plus G2 G3 H1 plus G2 H2 plus G2 G3 G4 H3 minus G5 plus G2 G6 H3 minus G2 H2 G5 minus G2 G5 G6 H3. So this is the transfer function of the given problem. So sometimes there is a chance to ask questions like this: convert the given block diagram to the signal flow graph and determine the transfer function. So very simple way to solve this type of problems. First of all, replace all the summing points and branch points with respect to the nodes. So replace all the summing points and branch points with respect to the nodes. So here there is a summing point, there is a branch point, some branch point, summing point. So I can replace all with respect to the nodes. So this is node 1 as input R of S. There is a summing point, there is a branch point, another branch point, another summing point, and output node C of S. 2, 3, 4, 5, 6. So we can write directly here 1, 2, 3, 4, 5 and 6. So this is a forward path as per the directions given in the signal flow graph. So if there is no gain is available, I can write 1. Between 2 to 3 also nothing is present, I can write 1. Between 3 to 4 I am having G4 in the given direction. Between 4 to 5 G2 is there in the given direction. In 5 to 6 there is nothing, so I can write 1. And from 3 to 5 there is another gain G3. From 3 to 5 another gain G3. Between 4 to 2 there is a feedback H. With the signal minus, so I can write minus H. So this is what our signal flow graph, which is converted from this block diagram technique. So block diagram, and this is our signal flow graph. For this I have to calculate the transfer function by using Mason's gain formula. So here same steps. Step number 1, calculating number of forward paths k, which is equal to, so this is the first forward path. So the gain P1 can be written as 1 into G4 G2. So this will be G2 into this is G1, sorry, this is G1 into G2, G1 into G2. So second forward path is directly G3, and if I calculate the individual loop gains, so here one loop is there, and only one loop is there. So there are two number of forward paths, and the individual loop gains are G1 into H1, G1 into H. Only one loop is there, G1 into H. So there are no another loop, so there will be no two non-touching loops. So the remaining all will be zeros. So there is no two non-touching loops. Two non-touching loops are 0 because we are having only one loop. So everything will become 0 now. And part of the graph which is non-touching with this, so that is the calculation of delta 1, and this first forward path it is touching all the nodes, and the second forward path it is like this, and there is no part of the graph which is non touching with this signal flow graph. So it's very simple to write now. The value of transfer function T can be written as P1 delta 1 plus P2 delta 2 divided by delta. So directly I am writing here P1 is G1 into G2, delta 1 is 1 plus P2 into delta 2, P2 is G3 minus G3 so P2 is here minus, so minus G3 and delta 2 is 1 divided by delta. So delta is 1 minus of individual loop gains. Individual loop gain is minus g1 into h. 1 minus of minus g1 into h. So their transfer function will be g1 g2 plus minus g3 divided by 1 plus g1 into h. So this is the transfer function from this block diagram.